All right, so to review, this is a review, not a quiz. We're going to take a look at all the possible questions I might ask you, at least not word problem based, or the tasks and skills you need to be able to work with sequences in series. So, if we take a look at those, first we need to identify or distinguish between arithmetic and geometric. So we're going to take a look at these numbers and look at the pattern. Again, it's just pattern recognition. So if all we're doing is figuring out it's adding or multiplying, then it's pretty clear to see in this first example that we're multiplying by, what number? By 3. So 36 times 3 is going to give us the missing term 108. That is geometric. Our recursive form, which I'll go ahead and do, a sub n equals a sub n minus 1 times 3, right? And so our standard form, remember, we're going to need A1 and R for that, or D in the case of an arithmetic sequence. So we've got A sub n is going to equal 4. Common ratio was 3, and we're just going to snap that n minus 1 up to the top. And then, of course, here we're asked to find the sum of the first 7 terms. So at the bottom, if you'll notice, the related formulas are here. So this is arithmetic. This is going to be a finite geometric, and this will be the infinite geometric. So I think you're given those on your formula sheet for the final exam, so take advantage of that. Just make sure you know which is which. Right, so for this particular one, number 1, we're going to use the finite geometric, so we need A1, R, and N. So of course, to figure that out, we've got A sub 1, which is what? 4, 1 minus 3 to the 7th power. All that's going to be over 1 minus 3. So take a second and calculate what that is. Boom, there it is, the magic of camera. How about that? All right, so make sure you understand which formula, the fact that it's geometric, distinguishing it from arithmetic, so on and so forth. So this one, we're going to work backwards. Let's get a different color. All right, so working with this standard form, we know the first term is going to be 27, and we know that the pattern is going to be subtracting 5. So 22, 17, 12, well, that's enough. It is arithmetic because it's subtracting. Again, that would be the same as adding negative 5. So we have a sub n equals a sub n minus 1, subtract 5. To go from one term to the next, you simply subtract 5. All right, and so here we're looking for the sum of the first 20 terms. So remember, the formula for that is the arithmetic sum, which is basically just finding the average of the first and last term and multiplying that by however many terms you're summing. So using that approach here, we're going to have 20 times the average of 27, which is our first term, and whatever our 20th term would be. So I'm going to go back to the formula to find that. 20 minus 1 is 19 times 5. What's that? 95. So 27 minus 95. Kind of tough to do in our heads. Oh, it's negative 68. Negative 68 there. And do some typing in our calculator. See, 27 minus 68 divided by 2 times 20. All right, so we're getting negative 410. And it makes sense if we get a negative sum here because these numbers are quickly going to become negative here in about 2 or 3 terms. All right, moving on to the next one. Oh no, fractions are involved. So take a look at this sequence. 2 4/3, 8/9, some missing term, and then 32 81st. So how do we go from 2 to 4/3? Well, 2 is the same as 6/3, so I could be subtracting 2/3. But if I subtract 2/3 from 4/3, I'm going to get 1/3, and that's not equal to 8/9. So this is clearly not arithmetic. It is going to be geometric. So we're going to look at, okay, if I have 6/3, let's cross that out and replace that with 6/3. It might be easier to see. Might not be. Then what am I actually doing to go from this number to that? Go from 6/3 to 4/3. Well, let's focus first and see if that might help a little bit. All right, so looking at this problem, it might help to put it in 6/3. It might help to go back and think about it as a 2. So what can I do to 2 to get 4/3? We said it's not going to be addition or subtraction. It's actually going to be multiplying 2/3. And again, how I saw that, I looked at, well, 4 times 2, 3 times 3 to get the 8/9. So if we go back and we think 2 is really 2 over 1, then 2/3 of 2 is 4/3. So we're basically multiplying by 2/3 each time, and 8/9 times 2/3 becomes 16 over 27. And you can try it there to go times 2/3, you get the 32 over 81. So we have our formula here. Our first term was 2. We are multiplying to 2/3 to the n minus 1. And it makes sense that this is 2/3 because our numbers are indeed getting smaller. Okay? Check out the recursive formula. Oh, they gave it to us. We did all that work. How about that? All right. So it won't hurt you. It's good thinking. So what we're looking at now, the sum of the entire series. How do I know it's the entire one? Because it says infinity. So this is a little contrary to common sense, but we're thinking about the fact that we're going to add up the numbers forever. The numbers do get smaller. So as we said in class, this series is going to converge. So we've got a simple formula, a sub 1 over 1 minus r. So the first term was 2 over 1 minus 2/3. Right, so that's going to be 2 over 1/3 or 6. All right, moving on. The next example, we want to figure out, okay, is it arithmetic or geometric? Take a look at the fact that these all have the same denominator and the numerator is merely increasing by 2. That means it's going to be arithmetic. So we're basically adding 2/4 each time. All right, and that's kind of really just saying I'm adding a half each time. So our first term is going to be 1/4 and our fifth one here is going to be 9/4. So we have a sub n equals 1/4 plus 1/2, which is the same thing as 2/4, times n minus 1. Or I want to write the recursive notation a little bit different this time. A n plus 1, which is like the next term, is using the current term and adding 1/2. And we want to find the sum of the first 40 terms. So we're going to have 40 times the average of our first and last term, 1/4. And how do I find the last term? I'm going to plug 40 in for the n here. So that means I'm going to add 39 halves to 1/4. All right, 39 halves to 1/4. All right, so there we get 79/4. And all that's going to be divided by 2. All right, so that's nice and convenient because 79/4 and 1/4 makes 80. 80 over 4 makes 20. 20 over 2 makes 10. And 400 times 10, 40 times 10, 400. Hopefully that's not freaky wrong. All right, I think I approve. All right, moving on to the next example. We should identify it immediately as geometric based on the exponential form. So geometric, first term is clearly 2. The pattern is times 5. So 10, 50, 250. All right, we have a sub n equals a sub n minus 1 times 5. And we're going to find the sum of the first 8 terms. These numbers are getting larger, so we cannot find the infinite sum here, but that's okay. They're only asking us to find the sum of the first 8. As I mentioned in class, we're going to do this one by the bicycle. So all we're going to do is find the first 8 terms and then add them by hand. Of course, we can do it in the formula, or if you're technologically savvy, we're just going to plug that in the calculator. Yep, exactly as you see it. Okay, but anyways, we'll take the bike just to reiterate that you can indeed take the slow method because the math is still correct. So times 5, we're going to have 1250 times 5. Ooh, yikes, what is that? 6250 times 5. Yeah, you see why you don't want to do the bike if you don't have a calculator? And then if you have a calculator, what's the point? All right. I'm going to wuss out here and go to my formula. So this was geometric, right? I've got the finite geometric sum. So I have a sub 1, which is 2. 1 minus 5 to the what power? The 8th power. All of that over 1 minus 5. All right, let's see what that equals. So what that equals, come on, focus. There we go. 195,312. In the midst of doing some of those calculations, you get some negative numbers that pop up. Yeah. But there's impossible for this one to have a negative sum because we're simply adding positive numbers. So make sure when you go back and you check your answers, do they make sense? Do they have the right sign? All right. This next example, next to last one, is clearly arithmetic. We're adding 5, right? So it's arithmetic. We're going to say a sub n equals negative 16 plus 5 times n minus 1. Or our recursive format, n plus 1, equals a sub n, and then plus 5. So just add 5. So find the sum of the first 50 terms. That would not be one you want to do on the bike, right? So we're going to take our arithmetic, our partial sum here. We've got 50 numbers we want to add, and we're going to convert all of them to the average of the first, which is negative 16, and the 50th, which will be, let's see, 50 times 5 is 250, so we got 245 minus 16, 229. All that's going to be over 2. All right, so we'll type that in. Let's see, negative 16 plus 229. Of course, it goes out of focus. Yeah, okay. That's cool then. Divided by 2 times 50. All right, 5325. All right, why does a positive answer make sense for that one? Well, we only got 4 negative numbers. After that, they're all going to be positive, aren't they? All right, so last one, arithmetic or geometric. Look at the form. It's arithmetic. First term, clearly negative 32. So let's look at the pattern and then just find the first 3. So we're adding 10, 22, negative 12, dot, dot, dot. All right, dot, dot, dot. A sub n equals a sub n minus 1 plus 10. And they want us to find the sum of the first 100 terms, not something you want to do by hand. So I can't remember what the famous mathematician's story was. His teacher gave him busy work. And it's supposed to take a long time, and he did it in a couple of minutes because he figured out the pattern and the formula. So don't discredit the pattern. We have 100, and then first term is negative 32. The 100th term, so we're going to add 199 times, right? So if I add it 100 times, we're going to add 10 100 times rather. So that would be 1,000. Take away one of those 10s. 990 minus 32. 958. All that's over 2. Okay. So good to typing. Negative 32 plus 958 divided by 2 times 100. 46,300. So these numbers, all right, we're adding 100 of them. That makes sense. That's a pretty large number. Again, go back through. Understand which formulas apply when, right? Finite geometric, infinite geometric, arithmetic. Obviously a partial because we have a value for n that is not infinity. So good luck. I'll see you Monday for the test.